All right, another one. Same shirt means I did it back to back. It is what it is. Um, okay, why didn't the melons get married? Because they can't elope. They can't elope. If you don't know cantaloupes, then you need to eat more fruits. Okay, so today, or I guess this video, welcome back. We are going to cover the fundamental theorem of calculus. Okay, fundamental theorem. This is the way. I don't know what to call it. I wrote here, it's how we algebraically calculate the value of an integral. Now, I don't know if you remember from last lesson, we were just kind of doing it by recognizing the shapes that we know, right? But then it immediately becomes an issue when we start to try to find the area under a curve, which we kind of don't know really how to do. Could be different parabolas, could be exponentials, hard to do. We could only do these ones because we knew what the shapes were. We knew how to find the areas. Now, this is the algebraic way that we do it. Okay, that means we can calculate it accurately. We're not kind of guessing, and it will be kind of, yeah, how we find the value of an integral, or in other words, it's how we find the exact area under a curve. Okay, so now this formula will become very, very important. Now, before we can get to the fundamental theorem and what it actually is, you guys do need to remember how to do your primitives. Okay, now you've touched on this briefly in year 11. You didn't spend a lot of time on it, but remember, a primitive is kind of like the opposite of deriving. So sometimes they call it antiderivatives. Now, it's just this little formula here. I'll explain it as we go, but they say if dy dx, so that means if the differentiated version is x to the power of some number n, then that means y, which is the undifferentiated version. That means you add 1 to the power. So that means instead of x to the n, it's now x to the n plus 1. And then it's all over. You divide it by that new power, which is n plus 1. And then we have this plus c, which is a constant because, yeah, that could be any number, and when you differentiate, it disappears. So let's do a couple examples, and hopefully it will jog your memory on what a primitive is and how to do it. And this will be the baseline for how we use the fundamental theorem. So if dy dx equals x to the power of 3, then I'm looking for y. I want to find the primitive, which is the non-differentiated version. And so it says here, I add 1 to the power. So that means x to the power of 4. And then I also need to divide by that new power. So that means I just divide it by the new power, which is 4. So if the differentiated version was x to the power of 3, my undifferentiated version is x to the power of 4 on 4. Now don't forget, we also need that plus c. Okay, primitives. Again, let's look at this one, b. So we've got dy dx equals to 3x squared minus 2x plus 5. If it looks a little bit messy, let's tackle it term by term. Okay, so what's going to happen here is I'm going to go 3, and the only thing that integrates is the powers of x. Don't worry about the numbers. The only thing that we're affecting is the powers of x. So I'm going to have 3x, and then I'm going to raise it. So 2 plus 1, I'm going to raise it by 1 power to the power of 3. If I raise it to the power of 3, I need to divide the whole thing by 3. Same thing for this one, minus 2, and that's x to the power of 1. So I'm going to raise it to x squared, and then divide it by the new power. And then if it's just a singular term, we add an x to it. So it just now becomes 5x. So it's in the same way that if I was to differentiate these ones now, I would end up back at the original. So I'm going to clean this one up here just a little bit. Those ones will cancel out, leaving me with x cubed minus x squared plus 5x. Don't forget, plus c, almost forgot there. Now, the way that this works is if I go y dash and I go back again, what am I left with? I'm left with 4x cubed on 4, which is x to the power of 3. And notice how that is the same as that. That's how you know you've done your primitives correctly. If you differentiate it and then you kind of get back. Same thing here. If I go back to y dash, that becomes 3x squared minus 2x plus 5. And take a look at that. It looks exactly the same as what we had. So that's what the primitive is. It's the opposite, or it's going backwards, the antiderivative, so to speak. Okay, good. Now that was a mouthful. Now that we remember, hopefully we've rejogged our memory how to find primitives, let's talk about the fundamental theorem of calculus. Now, I've left a little bit of space here so we can actually talk about what it is. So this here is going to be our, think of that as your lower bound. Think of this here as your upper bound. I'll explain what those mean. We're going to have the function, this dx, that x there tells us what respect to integrate. And it's going to look messy and full on, but pause the video if you need to write this. Yeah, what respect to integrate. So when I say what respect, what I mean by that is, am I integrating the x's? Am I integrating the y's? What part gets integrated? For the time being, you're only going to be working with x. Later on down the line, you might be integrating dt, dy, all these different things. For the moment, we're just going to stick with dx. Now, capital F, that's another way to say the primitive of lowercase fx. Okay, so if it's big capital F, it means we've done the primitive. And again, we can see the b and the a, we just substitute those in. Okay, so that there is the fundamental theorem of calculus. If you integrate fx between a and b, we'll get the primitive, substitute in b, take away the primitive with the substitution of a. Now again, probably looks a little bit full on at first, but let's do some examples and let's show you that it's not a scary process. Okay, now let's work through some of these together. The way that they'll ask the question is they'll say evaluate the following definite integrals. Now, definite integrals just means that you have these numbers here. Okay, sometimes you'll have indefinite, and so you can't really evaluate anything. You just have to write plus c. But if it says definite, that means we can actually substitute it in and get an actual number answer. So let's work with this. The first thing that we want to do when we've got an integral like this is we want to find the primitive first. So let's find the primitive. If we know that it's 4x is the equation, the primitive, I'll go 4x squared, and I would divide it by the new power, which is now 2. Okay, now I'm going to do these square brackets, and this is the notation that we use. Those square brackets kind of tell me that, okay, I have now integrated, but now I'm still going to write the -1 and 3 next to it to show that I'm evaluating it between these two places. Now, again, I'm going to clean this up a little bit to make my life easier. 4x squared over 2, that's just the same thing as saying 2x squared. Okay, and I'm going to still write that -1 and 3. Now, if you remember, going back to this formula here, we've got, I'll write it down here, f of b take away f of a. And so that's what we're going to do. We're going to substitute in the upper limit, and we're going to take away the substitution of the lower limit. So all that really means is I'm going to have this. I'm going to have 2, and then instead of writing x squared, I'm going to substitute in 3 squared. Right? Or sorry, I should put the brackets here. 2 times 3 squared. And then I'm going to take away what would happen if I substitute in 2 times -1 squared. Okay. And so here, if I was just to calculate it, that'll be 2 times 9, which is 18. And I'm going to take away 2 times -1 squared is +1. So just take away 2. 18 take away 2 is 16 units squared. And that there would be my answer. Okay, a little bit of a process. So you always do the primitive, and then you substitute in the values, and then you take them away from each other. Okay, let's try something like this. Hopefully, the more that you see this, the easier it will become. Now let's take a look. I'm going to use a different color so I don't get confused here. All right, so let's take a look. I've got 2x, or the integration of 2x plus 6 between 5 and 3. And so again, first thing I'm going to do is find my primitive. So in this case, it's going to be 2x and add 1 power to the x, which makes it 2x squared, divided by the power. And then plus 6. Now remember, with that 6, now a value, a power of x is now added onto it, right? And I'm going to use those square brackets like I did before, and we're integrating between 3 and 5. Now, again, to clean this up a little bit, that's going to cancel out, just going to make my life easier. X squared plus 6x. That's now my integration between 5 and 3. Now, to evaluate it, we substitute in the top value, and then we substitute in the bottom value, and we minus them from each other. So this is going to be 5 squared plus 6 times 5. And I'm going to take away 3 squared plus 6 times 3. Just substituting in those values. And let's see what that gives us. 25 plus 30, 25 plus 30. I'm doing this all in my head. 55. Take away what's 9 plus 18, 27. 55 take away 27 should be 28. Okay, 28. That's your answer, 28 units squared. Hopefully this is making sense. Okay, now if we have something like this, we can't really integrate something that's a product. So what we're going to do is we're going to make our life a little bit easier. We're going to expand the brackets now. Now this goes to x squared plus 7x plus 12 dx. Okay, I know that becomes my, let's have a little bit of a separation here so we don't get confused. So I've just expanded the brackets first, and now I can integrate each term individually, right? And we know it's between 0 and 2. So let's calculate this. This now becomes x to the power of 3, adding 1 to the power, divided by the new power, plus 7x squared plus 12x. And again, this whole thing, I'm going to put square brackets. I'm evaluating between 0 and 2. Now, to calculate this, it'll be 2 to the power of 3 on 3. Substituting in the 2 first, 7 times 2 squared plus 12 times 2. And now take away what happens when we substitute in 0 for everything. So it's going to be 0 cubed is just 0, 0 on 3 plus 7 times 0 plus 12 times 0, which is 0. Sorry, it's getting a little bit squished. But you'll find that once you calculate it, you'll just be left with, at this point, it's just arithmetic. Okay, now I know this has been a little bit long, but let me do one last example before I leave you guys to it. All right, now with a question like this, okay, we have trouble integrating products. We're also going to have trouble integrating fractions. Now we've got this giant fraction here, but what we can do is minus 3, minus 4, we can manipulate it a little bit. Oh, there's a math word. But let's just break it up. So it's going to be the same thing as 2x squared on x plus 3x on x dx. And so I can cancel out the x's. So whenever you got a fraction, see if you can separate them and cancel out some terms. And again, I'll be left with between minus 3 and minus 4. That's just going to leave me with 2x here and then plus 3. That's all that is, dx. Okay, now time to integrate it. I'm going to move on down here. 2x becomes 2x squared, adding 1 to the power of x, dividing by that new power. And then same with the 3. 3 becomes 3x. And we're integrating this. We're defining it between -3, -4. Okay, now again, a nicer way to say that would be x squared plus 3x. Again, between -3 and 4. And now we just substitute in the values, top first, and then we take away the bottom. Now, one thing that I should note here, be very careful with your bracketing. Okay, so I'm going to do giant brackets here so I can see what's going on. So I'm going to do -3 squared plus 3 times -3. That's the first bracket. Now take away what happens when I substitute in -4 as x. I get -4 squared plus 3 times -4. And now I just calculate this. You can do this in the calculator or in your head. I know that that's going to be +9. Take away 9. Interesting. That's going to be 0. And then I'm going to minus. And that's going to be +16. negative 4 squared, but then it's going to be plus, or what's going to be minus 12. Minus 12. Okay, so that gives me 0, take away 4, and so my answer would be minus 4 units squared. And sometimes that happens, sometimes you will get a negative answer, but as long as you kind of follow the steps, that there is what the fundamental theorem of calculus is. It's knowing how to integrate between, I guess, two separate numbers. Now, I guess what will happen over the next couple lessons is we'll show you how conceptually, so seeing all those shapes and how the algebra, how they kind of work together. But for the moment, that's what it is. Hopefully that wasn't too hard to follow. Again, if it was, please leave a question in the comments. If you liked it, you know what? Give us a like. Even better, subscribe. Make me money. See if I don't know, whatever. All right. Anyway, guys, hope you enjoy. I'll catch you later. Bye-bye.